So now we are solving question 8. Okay, question 8, and we've been given two matrices. Okay, two matrices, and we are told that if R, right, R is equal to x, y, no, this not correct.
Y,
Okay, thank you very much. And A, please can you mute your microphones? Like someone's, can you all mute your microphones, please? Hello. Okay, I think it's better now. So now R is equal to x, y, I. Okay, and the vector A is equal to 1 0 g 0 1 f g f c. Right. Now we are being asked to show that these questions are one of my favorites. When you get it wrong, then your heart is going some way. So show that R transpose, right? We did this yesterday. Okay. AR is equal to 0. Okay. Is the equation of the circle in R square with center negative g negative f and radius the square root of g square plus f square minus c. I hope you are watching along. Okay, so this is R transpose multiplied by the matrix A times R. Okay, now this is R, right? What is R transpose? As I said, R transpose, we just invert the position. So this is a n by 1 matrix. So now inverting it, right, we get a 1 by n matrix. Okay, so now we get something like x y I, right? We get something like this. Okay, multiply. Okay, so this is the R transpose. Okay, so now R transpose AR, right, is equal to this x y I, right, multiplying 109 g 01 f GFC. So you can be solving along. Okay, you can be solving along. Like you can try to go ahead of me because I'm solving it slowly. So you can try and go ahead of me. Then you see if you're on track. Okay. So now this is the matrix that we have. Okay. Now as I said, you can multiply matrices if okay. So you can multiply matrix A and B, right? If the column number of A is equal to the row number of B. So if A was a n by p matrix and b was a c by c matrix, p and c should be equal, right? And the resulting matrix will be a n by t matrix. Okay, we did this yesterday. All right, so now this is a 1 by 3 matrix, this is a 3 by 3 matrix, and this is a 3 by 1 matrix. Now the column number of the first is equal to the row number of the second, and the row number of the first is equal to the column number of the second, right? So it means that we can multiply. Do you get? All right. So which one should we do first? So let's multiply the one. So let's multiply this R transpose with the matrix A. Okay. Now, so in multiplication, in multiplying of matrices, right? This this row, right, multiplies this column, and this column again multiplies the next in that order, right? And as I said, you end up getting a 1 by 3 matrix. Okay, 1 by 3, one row, 3 columns. Do we get it? If you are new here or this is your first time, the row is the horizontal one, okay, and the column is the vertical one. Okay, so the result being a 1 by 3 matrix means that you get a matrix in this form: one row, 3 columns. I'm not communicating. But if you don't get me, you can pause. Okay, I'll not be going back to the chat, so you can just give me a unmute and speak. Okay, Now most I'll do this quickly, okay, so that we just move on quickly. So multiplying this by this and this by this and this by this, okay, we get x times I, right? So x, right, and we get y times 0, which is 0, okay, and we get 1 times g, and we add them, okay. So this we've done over here is giving us one term. This x plus g is actually one term. Don't be tempted to separate them. Like if you are confused with something like this, okay, you can just replace them with numbers, okay, and multiply and see that with the numbers, will I be adding or will I be separating? Okay. Then we come back and do so with the variables, because sometimes with the variables you are tempted to like separate them as individual terms. Do you get? So now we get x plus g as our first term. We do so for the second one. We get y plus f, right? And finally we get gx plus fy plus c, okay, multiplying x y I, okay, right? So now we continue again. So this is a 1 by 3 matrix and this is a 3 by 1 matrix, right? So our resulting matrix should be a 1 by 1 matrix. I'm not communicating, okay. Now, so multiplying this together, we get, you can do it so quickly, but I've already multiplied this somewhere, okay. So you will end up getting let's see, this is this x plus g is multiplying this x, so we get x squared plus gx, okay. This is multiplying y, like y plus f is multiplying y, so we get y squared plus fy, right? And this is being multiplied by 1, so we get the original expression back, right? And in the question, right, we are told that show that show that r transpose, right, multiplying the matrix A times R is equal to 0, right? It's the equation of a circle, okay. So this value that we have equal to 0 is equal to the equation of a circle. Now let's try and simplify this expression we have. Expression, so we get x squared, right? We have gx here and gx there, so we get plus 2gx, okay. Okay, let me just do so in order, okay, that one will be better. So we have y squared, right, plus x squared, this x squared, so y squared plus x squared. We have gx over here, gx over here, so we get 2gx, right? Now we have fy here, fy here, we get plus 2fy plus c, and this is equal to 0. Now this is the equation of a circle, okay. Then we are done proving it. So as I said, in matrix multiplication, don't expect that they'll give you a times b for 50 marks. No, sometimes you need some general knowledge on certain concepts to be able to solve the questions, okay. And this was a clear example, so let me save this quickly.